So in this video, I'm going to cover a common mistake some students make when calculating empirical formula. Hi, my name is Jeremy from the classroom, and let's look at this question. So here we're told that you have you have an oxide of nitrogen. It contains 0.35 grams of nitrogen and 0.8 grams of oxygen. So now, because some students think that nitrogen gas is N2 and oxygen gas is O2, this is what they do wrongly. So they start by writing N2 and they write O2. Okay, so this is of course a misconception, and what they will do is after that they will write the mass, and this is 0.35, 0.80, this is in grams. Okay, they will write the AR or they will write the MR as 28 and 32, which is not correct. Okay, so you must be very clear that when you're calculating empirical formula, you want to write the AR of the atom. Alright, it doesn't matter that nitrogen and oxygen exist as N2 and O2. Yes, that's correct. But when you want to calculate the empirical formula, we write N and O. So I'm going to do it in blue color to show you what the correct steps are. So don't make the mistake of writing that. Instead, what you want to do is you want to write N and O. Okay? And then you want to construct the same table, and the table should have one row for mass, AR, moles, and ratio. Okay, so if you didn't catch that, once again, we have mass in grams, we have AR, we have mole, and we have ratio. Okay, mass is given in the question 0.35 and 0.8. AR, you can get the values in the periodic table. Nitrogen is 14 and oxygen is 16. We take the number below, yeah? So it's 14 and 16. Second mistake some students make, because rusty, cannot recall, they use the wrong AR. They use a number on top. No, the AR is a number below. Watch out for that. And then, so find moles, you have 0.025 and 0.05. Okay? And the last step involves finding the ratio. So now that you know it's 0.025 to 0.05, the simplest ratio, you divide by the smaller decimal, 1:2. And therefore it's NO2. Alright, so that's your empirical formula. So two mistakes you don't want to make. Number one, make sure you don't write the the formula of the molecule. Number two, please make sure you don't use the wrong number. That's your number of protons. What you want to use is you want to use this, okay, the number below. Now, so this gives you answer for part A, part 1. Part 2, alright, now we don't know, so this is the empirical formula, yeah, empirical formula. And the empirical formula gives us the simplest ratio. So we don't know if the actual formula is NO2, N2O4, N3O6. To find the actual formula, all right, they're going to give us the MR, 46. So now we know that it's NO2, but it's repeated N times, and that gives us 46. All right, so we know that N is 14, and oxygen is 16, times 2, times N is 46. Okay, so if you do 32 and 14, that gives you 46. N is 46. And it so happens that N is equals to 1. So for this particular question, the empirical formula is what? Same as because it's N1, or rather it's NO2, let me just, NO2 multiplied by 1, which still gives us NO2. So for this particular question, the empirical formula and the molecular formula are the same. So you want to watch out for that. So two commonly made mistakes. Once again, number one, all right, if you're given diatomic molecules, chlorine, fluorine, bromine, oxygen, nitrogen, all right, you want to make sure that you write them as atoms here, and make sure you do not use your number of protons. All right, okay, so watch out for that.